So for number 11, the question is, or the blurb says, the true mean GPA at a school is 3.25. A random sample of 50 50 athletes had a mean of 3.16. So that's n equal to 50. X bar is equal to 3.16, and the standard deviation of 0.37. A formal hypothesis test to determine whether athletes have a different mean GPA than all students. Well, all students are stated to have a mean GPA of 3.25, so that would be the assumed value, the null hypothesis. The alternative would be that it would be different from that. All right, so we need to determine, well, we use a hypothesis test, but we need to determine the results for all of these little bits and pieces. So that's where the fun part begins, I guess. So the alpha value, it says perform a formal hypothesis test. It didn't say anything about at a particular level. So we get to decide on whatever level we want. Typically, we choose 0.05 if we're left to decide for ourselves. Right? So 0.05 it is. But you can't go wrong. If you do 0.05, 0.01, or 0.10, then you're fine. Any of those are okay. Right? So we have a sample size of 50. They don't say anything about the distribution being normal, and they didn't give us a sigma value. All right, so all we have is the sample standard deviation. So this has to be a t distribution. All right, so this is a student t distribution, is the official name for it. All right, now it is cut off somewhat, so the next step would be to determine the test statistic. I'm only asking you for the answer here. So what I'm going to do is open the t-test calculator. So I just got to go grab my t-test calculator. All right, so for the test statistic, I got to put all my bits and pieces in here. So 0.05 is good. 50 is the n value. Degrees of freedom. All right, in terms of what they're asking us for here, they didn't ask us for degrees of freedom, so at least in this, but in the directions it said be sure to include. It was a practice assessment, so in this case we could assume that means to be prepared to include. All right, so the test statistic is what we're looking for next. All right, so critical values, we'll cross that bridge. Might as well get it all, or at least have access to it. We're not asked for any of that, so that's fine. So we could take note of this. This is where you'd find it if you needed it. I like to look at it though, just to make sure. This would be a two-tailed situation. So I'm going to turn on the two tails, just so I have it nice and visible in my graph. All right, for my statistics, my sample mean was 3.16. I'm going to type that in. My sample standard deviation, 0.37. So I'll close that up now. My parameters, they said to assume a 3.25. All right, that's my mu equals mu sub 0. All right, so the mu sub 0 we're assuming is 3.25. So that makes the test statistic t equals negative 1 point, if we're rounding to 3 significant, 720. All right, so in the answer field here you could write just a negative 1.720, or you could write t equals negative 1.720 either way. All right, So then for the p-value, I just jump down to the one that says two-tailed. The p-value, 3 significant again. 0.0917. All right, so they ask if we're going to reject the null hypothesis. Well, this number, this p-value is not less than the alpha value. Also, if I'm looking at my graph here, my test statistic is negative 1.7-ish, right? My critical values has got it in the neighborhood of -2. Negative 1.7, that's going to be just a little bit to the right of that -2, not going to fall in the rejection region. All right, so the p-value is not less than the alpha, and my test statistic does not fall in the rejection region. So reject the null hypothesis, the answer is no. And so then it's just a matter of writing the conclusion out. All right, so there is insufficient evidence to reject the claim that the population mean GPA is 3.25 at the 0.05 significance level. So first sentence addresses the null hypothesis. The second sentence answers the question whether athletes have different mean GPA than all students. So therefore the claim, so 3 dots in the form of a triangle. I'm going to write it here, but you'd write it out on the test. 3 dots in the form of a triangle means therefore the claim that student athletes, or, well, I keep saying student athletes, but it's just athletes who happen to be students, have a different mean GPA than all students is false. So it depends on what the purpose of the study is, but this is basically saying that there is no reason to think that the athletes would have any significantly different GPA than any other student. Right? So if they're trying to show that maybe athletes are more dedicated due to discipline and all that stuff, and therefore that translates to their studies. They didn't show that, but if somebody wanted to show that, the whole dumb jock thing, they didn't show that either. Right? They're showing that they're the same as everyone else. Right? Just based off of this study, though. Right? So that's a sample of only 50 values, so you never know. All right. Number 12. The size of a tip that a waiter or waitress receives is determined in part by the behavior of the server. A study was conducted to test the hypothesis that servers who squat to the level of their customers would receive a larger tip. In the experiment, the waiter would flip a coin to determine whether he would stand or squat next to the table. The waiter would record the amount of the bill and the tip, and whether he stood or squatted. Would this be an observational study or an experiment? Well, this would be an experiment. I can't write. I don't even know why I tried going in script there. Experiment because a treatment is imposed and that's the whole idea of sitting or standing or squatting. It's the cause to determine an effect. Identify the explanatory and response variables. Okay, so the explanatory variable would be whether the individual stood or squatted. The response, amount of tip. All right. So the standing or squatting, that seems to be the only two variables that, or, I'm sorry, it's one variable. But the only two possible outcomes of that variable, which could be stance or some words to that effect, posture maybe. But since it's only limited to these two possible behaviors, and the individual who is conducting the study is the one who's carrying out these behaviors, you probably can assume that he's not going to deviate from that. All right. Factors that affect the response variable that could become lurking variables if they're not under control. So anything that would impact the amount of tip, well, it could be the other behaviors. Of the waiter. Could be the cost of the meal, the quality of the food, okay. So I mean, it is possible that being eye level with somebody could impact whether or not you make a connection with them and therefore feel more inclined to give them a bigger tip. But I'd like to think that probably whether you had a good experience in terms of whether you liked the food, whether the waiter was a nice person, they could look you right in the eye, but then call you a jerk. You're not going to give them a tip, Reasonable outcome of this study would be the more instances of eye-level communication would lead to greater tip, with the instances of eye-level communication being the squatting. Now it's possible the individuals are sitting at a high top table, so height of table. Maybe squatting would put you too low. Now they got to look down to see it. It's entirely possible. All right. Should randomization be used here? Why or why not? Yeah, because a person could subconsciously squat or not even realize that. I mean, I don't think they would subconsciously squat, but they make the decision to squat in instances where they thought that they were less likely to receive a tip for other reasons. All right, so yes removes any bias from the decision-making process. All right. You should always include randomization for just that very purpose, right? But the idea is that, let's say, for example, the individual just ordered like a pretzel and a glass of water, right? So not much of a, it's not going to be much of a tab. So even if they gave you 20%, it's still not going to be a whole heck of a lot of money. So you might subconsciously decide, well, I better put in a lot more effort with this individual to give them a better experience, in which case maybe they would give me 100% tip, or even maybe you'll set up for a 50% tip, but something other than the 20% tip, which might end up being like 50 cents. It might not be significant. All right, so So that's some stuff that could come into play without you even realizing it. All right, so the next one, and really the last one, is before and after situation. So we know it's matched pairs because of that. We want to know whether or not there is a reduction in cholesterol levels. And so we're going to conduct this test at the 0.05 significance level. So what I need are the differences between these values, and I could do that in Desmos. All right, so I still have my t-test calculator open, so I'm just going to hang on to this. So what I'll do here is create a table. 6.2, 4.5, 7.3. I'm going to just put in these values. Seven, 6.6, 6, 3.5, 5, 4.7, 5.3, 6, and 5.4. All right, so what we're going to do is we're going to subtract these two values. You can call, if you want, retitle it B and A. Yeah, go to B and A. I think it's B and H actually. All right, B and A, and then find the difference. B minus A, and then find the summary statistics for that new column of information, which is going to be X bar sub D, S sub D, and N being the number of pairs of data. All right, that you don't need to look at the table for in Desmos, because you got 1, 2, 3, 4, 5, 6, 7 pairs of data, and also it says it right here. All right. So the B minus A values, you can just kind of tuck them in over here. 0.2, you got a 1, 2.3, negative 0.9, 1.5, 1, and then 1.2. You're going to find the average of these numbers and the standard deviation. So what I would do is go to function, stat, mean, B minus A, which is 0.9. Then I'm going to do the same thing just with standard deviation. So standard deviation, B minus A, and we're looking at to the nearest, or to 3 significant, 1.0132. All right. So if we're conducting the test to see if it lowered cholesterol levels, the null would be that there's no difference. The alternative would be that before the drug was administered, the cholesterol levels were higher than they would be after. All right, because it's a match pairs design, this would be a student T distribution, with the test statistic being T equal to, I apologize for the format, but that's the only way I knew how to do it. T is going to be equal to whatever it tells us it is. All right, so we're going to hang on to this information, start right at the top with our t-test calculator. Alpha, they said 0.05, that's the default, so that's good. 7, I'm going to pop in a 7 here. I'm going to trim my calculator a little bit. Critical values, not asked for critical values, just the p-value, but my critical region should be right-tailed, not two-tailed, so let me just fix that. My statistics, 0.9. And 1.0132. Parameter should be 0, right? Because if there's equality, that suggests that the difference between the population means is equal to 0. So I put in a parameter of 0. Close that up, and it spits out the t statistic, which is 2.350. P-value, I need the left-tailed p-value. I'm sorry, right-tailed p-value. That's this one. 0.0285. Now that p-value falls in the shaded area, right? But also the p-value, I'm sorry, the test statistic falls in the shaded area, but the p-value is less than the alpha, so we are going to reject, so that's a yes. So there is sufficient evidence to reject the claim of no difference in population mean cholesterol level before and after the treatment, the drug treatment, but treatment is fine, at the 0.05 level. Significance level, either way is fine. All right, so that's the null hypothesis. Now I just got to answer the question. Therefore, the claim that the drug lowers cholesterol is going to be true. All right, because we rejected the null, we rejected equality. So we're going with the alternative, which is corresponding with the idea that we're lowering cholesterol. So that makes that a true sentence. All right. So that's a two-population hypothesis test, specifically matched pairs. And then, as you know, the last question is where you could submit any supporting work for partial credit, especially for those multiple choice. All right. But then you also have the conditions of the assessment, so make sure you read through this. And yeah, so every one of them should get a check. Boom, boom, boom. I think there's 5. One of them got cut off, so I'll just put another check there.